Thank you very much, Giorgio. You will see that the title of my presentation here is a little bit different than what is in the book. I will try to give you the results of a large clinical trial we did a couple of years ago, but I will try to focus on some of the gut metabolites that could be explicative of the response that we are seeing. Before going any further, I'd just like to disclaim my long-term funding source, which is Dana Food and CIRC. Dana Food is a member of the neurophenol consortium, and I'm going to be talking about one product that they have developed, which is Cerebel, but is also known under a number of different names and marketed around the world. So we know in general that berries are good for health. They have a number of beneficial effects on cardiovascular health, on metabolic syndrome. That's probably the most important aspect of their effect on health. But we also know that they are also very important to prevent against cognitive decline. And the idea is, what is the mechanisms, and is it an improved blood flow? Is it improved neurogenesis? Is it a modification of the gut microbiota? Is it a modification of the immune system? So there are many different responses that we can attribute to these small fruits. And this is why we wanted to further this area of work. And you are certainly all familiar with this age pyramid of the world population, and it is the number of people above 65 years old will move from 5% to about 16% in the coming years. So it means that we need nutritional strategies to improve the cognitive decline that is associated with this normal aging. There was a very nice piece of work done by the group of Le Teneur in Bordeaux who showed that there was that the evolution of the cognitive function over a number of years was really slowed down in the groups of elderlies that were consuming high flavonoid diets. So it was improving the cognitive function. And the work of Krikorian in the United States has been he's been able to demonstrate the impact of anthocyanins in the case of grapes and berries on verbal learning memory and memory performance in general. And they were attributing the effect to specific anthocyanins on this improvement of memory. So in order to further the original ideas, we decided to create a consortium with 5 universities and 7 companies involved in different aspects of production of an extract or a supplement, which was rich in flavonoid, but in particular was rich in flavan-3-hols. And it was a proprietary mix of blueberries and grapeseed extract, but we were mostly interested not in the anthocyanin, but into the flavanol portion of these berries. And we created this extract that we called neurophenol. And we formulated the product, and we did in vitro preclinical trials, animal trials, and finally a human clinical trial that I will be reporting here. So we've published many papers out of the Neurophenol Research Consortium, and I'm going to be focusing on 2 specific papers and trying to relate to the role of the gut microbiota in the context of the results that we've obtained in these 2 papers. So let's first start with the animal research we did, and we evaluated the cognitive enhancing effect of polyphenol-rich extract, which is a neurophenol extract from fruit, on neuropathology in a model of Alzheimer's disease. So basically what we did in this experiment, we utilized old mice, either normal, non-transgenic, or a model of transgenic, tri-transgenic mice that were transformed with the presanilin, APP, and tau protein, a model that is known to develop memory deficit and neuropathy markers. And we fed the mice with either a controlled diet or the diet enriched with 500 milligrams per kilogram of this high flavonol supplement, or a 2,500 milligrams per kilogram of the supplement. And so we had the non-transgenic and the transgenic under the same conditions. So we fed the mice from 12th month to the 15th month, and we did a number of behavioral analysis at that point. And after the 16th month, we looked at the brain tissues to look at, in particular, some metabolomics analysis. So we submitted the mice to a battery of tests. And from what you can see here, I won't explain all the tests. The motor performance, anxiety, and the exploratory behavior were not significantly impacted by the consumption of the supplement. But as we saw from the previous speaker, and this is a response we see very often, memory and novel object recognition was much improved by the consumption of either the 2 doses in the control or in the transgenic mice, and this is mostly evident with the higher concentration. What we did then, we also look at neurogenesis, and in this case we could definitely find that there was an improvement in the neurogenesis through the brain-derived neurotrophic factor in both the normal mice and the transgenic mice. And we tried to correlate these responses with some of the circulating metabolites. And we could find some interesting metabolites that were correlating significantly with the responses we were observing. These metabolites are small microbial metabolites of flavantriols. They're gut metabolites, and one of them is the 2-hydroxybenzoic acid, the hydroxyphenyl propionic acid here, which is a terminal degradation product of flavantriol, and probably the most interesting and the one that is a lot of researchers are being interested in is dihydroxyphenyl valirolactone, which is a marker and a unique marker of the microbial metabolite from proanthocyanidin degradation and flavantriol degradation. And we could find that there was a very nice linear and significant correlation between the presence of this metabolite and the positive response that we were seeing in the cognitive function. So this led us to prepare a large clinical trial, and this clinical trial is called Neurophenol Clinical Trial. It was carried under the supervision of Véronique Palais and myself, both in France and Quebec. And we recruited about 100 subjects in 2 arms. basically a placebo arm, and one which was the supplementation with neurophenol extract. And you can see here part of the criteria that we were looking. So the average age of our group was 60 years old. They had a BMI between 20 and 30. Exclusion criteria: no consumption of food supplements containing polyphenols or omega-3 fatty acids. No symptoms of depression, schizophrenia, Alzheimer's disease, dementia, etc. No alcohol consumption, and we removed those that had a very high level of physical activity. And the food restriction was quite strict. We avoided, or we asked the participant to restrict themselves to 2 servings of polyphenols per week, 1 cup of tea per day, and a low quantity of chocolate-rich flavantriol. You can see here the baseline characteristics of our group. We had obviously more women than men. We recruited the same amount of participants in both France and at Laval University. Generally speaking, the education level was under 15 years of education, and about 76% had higher than 75 years. So that was about the baseline characteristics. So the way we ran the experiment, we supplied 300 milligram per day of that neurophenol extract or a placebo during 6 months every day. And at the beginning of the experiments or at the end of the experiment, we carried cognitive performance tests through using the Cantab battery of tests that you are all familiar with. And we were mostly interested in the PAL test, the paired associated learning, which was the primary outcome, but we also looked at a number of other parameters like the verbal recognition memory test. And then we took a number of biological measurements like heart rate, cholesterol, blood pressure, glycemia, insulinemia, etc. And we also did targeted metabolomics analysis on 24-hour urine collection. And we did that through UPLC and SMS, both at the beginning and at the end of the experiment. All these, throughout the experiment or the trial, we had the patients filling food frequency questionnaires. So I won't discuss the PAL test. I think most of you are familiar with it. I just want to maybe stress one point. This battery of tests has been filled or passed by a large number of subjects being enrolled in the Cantab, the different Cantab studies. And a nice correlation has been drawn over time through the different studies. And there's a nice linear relation that has been drawn between the increased number of errors that subjects are making and their cognitive age, cumulative cognitive age. And as you will see that I'm using this correlation at the end to show you how we have improved the cognition of the memory of the elderlies. And the verbal recognition test is basically remembering a list of different words that are submitted to the patients, and again looking at the number of correct response. So let's look at some of the results. this blueberry grapeseed extract, the effect on the whole cohort, at first were somehow not what we were hoping to see. Just for example, here the placebo, we over the 6 months of the treatment, we could see an improvement in the placebo, and in the again in the blueberry grapeseed extract, we could see like an improvement. But when we would compare the placebo or this change at the end to the placebo, we found no significant effect. So we were really disappointed from these results, but we went back and tried to stratify the groups based on the results of the PAL test at the beginning and at the end. I will show these results in the next slide, but I would like to stress that we could definitely see within the group of the different subjects, when we looked at the metabolomics of about 300 different compounds, we could see that the group consuming the grapeseed blueberry extract had a much higher concentration of the different polyphenol metabolites in their urine. And some of these metabolites were particularly in high concentration. Apart from epicatechin sulfate, which is a phase 2 metabolite of epicatechin, we were able to find that dihydroxyphenyl valerolactone was also excreted to large quantity. We could not distinguish at the time, since we did not have the standards, if they were phase 2 transform, if it was a sulfate, a methyl, or glucuronide. But generally speaking, we could see a higher concentration of valerolactone being excreted. And also epicatechin methyl sulfate here was one of the important compounds. So what we did was we looked at, we stratified our cohorts into 4 quartiles based on the response of the PAL test at the beginning. And we noticed that we had one group that we called the decliners, but those that did not respond well or did not have a high, or were making a lot of errors at the beginning of the experiment. And we looked also at the beginning of the experiment to see if this cohort here, this group, was different in specifically in behavioral activity, and we can see that age-wise they were the same age. Their education level was maybe a little lower than this first cohort that was very sharp. I don't want to make differences between the cohort in Quebec and in France, but Quebec City is a university city, and we were able to recruit in our cohort a lot of educated people, whereas in France the recruitment was made throughout France, both in rural and cities, so that might affect here this response. So we did the stratification. We looked at through the dietary polyphenol intake. We saw that this group, even though it was not significant or barely significant here, we saw that this cohort of decliners was consuming a little less polyphenols. But when we looked specifically at the flavantriols, we could not find any difference between all the groups. And we looked then at the urinary concentration of flavantriol and could find that this group was excreting a large amount of flavantriol, and in particular some valerolactone that they were excreting more. So we think that that might be one of the explanations for this response. So when we looked at the effect of the supplement for this subgroup, this quartile of decliners, we can see here again a strong impact of the extract on the PAL test. And when again we looked at the change from baseline, we can see a significant improvement. And when we look at how it translates in terms of cognition, we can see that the baseline, or the age of our groups at baseline for these was 65, but their cognitive age was 83 at baseline, and at the end of the experiment, we reached 69. So that's a 14-year difference in improvement in memory improvement. So that's quite a significant change. I would like to relate these compounds or this effect to some of the metabolites that are excreted by this group of decliners. We know that prosanidine, and they're basically proanthocyanidine, are polymers of epicatechin. They can be, in the case of blueberry, very large polymers, up to 30 units of epicatechin. And that the microbiota will degrade them in sole unit of epicatechin, and a class of microbes in the gut, namely Corynebacteriaceae, will open up the B ring and will generate the production of valerolactone. And some of the subjects have or not this this class of bacteria, and there's a large variation in the population for the production of this metabolite. We call that we have metabotype of the capacity and degradation of flavantriol. And here you can see this is the 12 people we had in an experiment in our lab, and we were looking at their capacity to degrade flavantriol. And you can see that some people have this capacity, they have the microbes to do it, and some don't have it at all. So that might explain some of the response we've seen from the large clinical trial relating to the presence or not of metabotypes in the population. And interestingly, we know that some of these metabolites have the capacity to cross the blood-brain barrier and affect to a certain extent the response or the response in the brain. I will terminate with this slide. I think many of you have explained the different routes by which some of the polyphenols metabolite can have an effect on brain. It can certainly be directly on short-chain fatty acids through either immune response, vagal or the production of enteroendocrine cell, through the vagal nerve have an impact, or through the biosynthesis of serotonin. So this metabolite, which we have measured, might act actually at a number of different levels. And recently we have shown specifically that it is involved in immunological response at the level of the gut enterocyte. And it leads us to production of Treg and might be involved in reduction of inflammation. So last slide, supplementation with blueberry grapeseed extract improve episodic memory in healthy people, age 60s to 70. In this population, about 25% present a deficit. It's a quartile which we measured. Episodic memory alteration may be reversed by the consumption of this extract. And catechin and their metabolite are probably responsible for maintaining the integrity of this episodic memory systems. So on this, thank you very much.